Hello everyone, we're going to discuss today Bernoulli equation experiment. In earlier video you should have seen the discussion that is related to the air bench. And the air bench is, as we discussed it before, is meant to provide a wind tunnel configuration that are simpler to deal with. And we can plug in different modules and do our experiments. So Bernoulli is one of the very important concepts in fluid mechanics. We rely on it in a lot of different applied fields, from flow of different liquids, water, oil, into also even flow of air at low speed, in HVAC calculations, and any type of airflow also that you can work with. As long as you're below the Mach value of 0.3, then Bernoulli is a concept that you can apply. Bernoulli meant to relate pressure and velocity. So in this experiment, you're going to see we're using pitted static tube, which takes the concept of Bernoulli equation and use this concept to measure velocity based in pressure measurements. The pitted static tube can be seen here, has two different ports on the top. One port is connected to the front of the pitted tube, which should be all the way at the end right there. Let me move it up a little bit. Okay, and you have very small side holes in this pitted static tube where it can measure the static pressure. So you have two different independent paths inside this tube. One is connected to the front of the tube that measures the total pressure, and the second is connected to the side of the tube, all around the side, and this measures the static pressure in that case. So using this with the manometer, you should be able to determine the pressure difference, and the pressure difference here will be equal to the velocity or term on the pressure equation, which we call it dynamic pressure. So with this, you can use the pitted static tube equation to determine the velocity by pressure measurements. So this is a very valuable concept. It's used in aircrafts to use pressure measurements, which is easy to conduct to get the velocity values. The pitted static tube meant to see how the cross-section area, the Bernoulli equation here, where we use the pitted static tube, meant to investigate how the cross-section area will change the speed of the flow, and we relate it to the theoretical values that you can get from the equations that are given in class. So you can see here, this module meant to have different cross-section area for the flow direction. Keep in mind that this will be turned upside down and installed, and this is what I'll show you this later on, in this machine where the flow comes from the top. You can see the 10 millimeter going down to 20, all the way down to 280 and even 290. We stop measurements around 280 because the flow quality becomes less and less as you go close to the exit. So you can see the cross-section area starts as big, gets smaller, constant from 60 to 100, and then gets bigger again as you go downstream of the flow direction. So with this, you can keep measuring at different location by changing the location of the pitted tube itself. You can untie this, move the pitted tube up and down to get different location of measurements. At that time, this should be connected to the pitted static tube should be connected to the manometer. So we can actually show you right now how we can connect both of them. So you can see that's one of the connections. Here, this is the one should measure the total pressure. And we take another port, which is number 5. I'll show you right now. We can actually connect the side pressure, which is the static pressure in our case. In reality, we're not really measuring the static and the total. We're measuring only the difference between them, because the manometer can only give you a difference in pressure, not actual value of pressure. So you can see here right now they're connected. And in a little bit, I will show you after we install the module here, how you can see the measurements and how we can actually control the location as well. So take me like a minute. For this experiment, you require to have your safety glasses on. You have airflow, you could get 10 degrees, so you want to make sure you stay safe by having the safety glasses on. So with this connected right now, you can see it's in the flow direction. As we said earlier, it's upside down compared to the original shape that we saw earlier. It goes from 10 downward all the way. You can always change the location of the pitot-static tube by moving it up and down. So right now it's exactly at 70 millimeter. And we take measurements. As you can see, they didn't give you a very specific order in the cross-section area, so they're not like always getting bigger or always getting smaller. They're actually different changes. This way you should see a changes of the velocity that correspond to the continuity equation that you already covered in fluid mechanics class. If I turn on the machine just to show you the actual values in the manometer, I'm gonna go around 50% of the machine, and that's just by using the dial that we have here. So right now at 50%. As you all know, the cross-section area, as it gets smaller, you get faster flow. So I'm gonna put it in the smallest cross-section area just to give an idea how this corresponds to pressure. So if you look at the values or the height of the manometer, you should see two locations that are connected. The total pressure should be connected to 3. That gives you the highest pressure value, which corresponds to the lowest level of water. The one on 5 right now is connected to the static pressure, which is a lot lower, even lower than the atmospheric, because you have high speed flow inside. So the atmospheric represented by all the other channels. You can see they're all in the same level. 5 is static, lower than the atmospheric. 3 is the total pressure. As you can see it right now, it's the lowest level that you can have in this experiment. You can see the value. I'm gonna try to fix it here while I'm changing the speed first. So if I increase the power of the machine, we should see this climbing up and down till it settles to a certain value. Okay. The other way to change this is actually to see how the cross-section area changes by moving the pitot-static tube itself. So I'm gonna move it to a new position which has a bigger cross-section area, and you start to see also the levels gets closer to each other. So I'm gonna move it even further down. You should see the effect on the measurements in the manometer. The equation of the manometer will be given in the lecture, as well as the pitot-static tube. It's usually covered in fluid mechanics class and aerodynamics classes. So lecture also going to review this material before discussing how to use this experiment. So the overall, you can see here, it's a simple experiment. We try to investigate the effect of different speeds, so we can actually repeat this experiment at different speeds, as well as the effect of the cross-section area on the velocity of the flow, as well as the flow rate here, which based on volumetric flow rate Q. Okay, with this, the lecture should give you the rest of the information to see how to analyze the data that you get from this experiment.